we'll write equations for basic rate problems using unit analysis. Okay. So looking at this, we've talked very briefly, and we indicated before that the way we do rate multiplications would help us out, kind of starting to think about writing equations for these types of problems in y equals mx plus b form. So we're going to go through and we'll set it all up just like we did before. So our answer sentence, it says, write an equation to represent the cost. Okay, so what we're thinking about here is we want to know the cost. So the cost is blank dollars. So as we start to set up our rate multiplication, we're thinking about it as blank dollars. As we go in through and we find our rate is $1.50 per song, so $1.50 for one song, or one song for $1.50. And the situation we're trying to find out about, this is a little bit different, is what? X songs. X songs. Yeah, so this is a little bit different because we're just being asked to write an equation. So we're writing an equation, and this is going to be one unknown, as we don't know how many dollars. That's what we're actually trying to find out. Match up our correct rate, $1.50 for one song. And we would multiply that by our X songs. And we know that because this will make our songs and our songs cancel out. And so we can simplify this now if we wanted to kind of get rid of all the extraneous symbols and all the extra stuff here. There's nothing left on the bottom of the fraction, so there's actually no reason to have that there. And so when we write this, we can write our final answer as this is y, which we know is going to be in dollars, is equal to $1.50 or 1.5. So 1.50 is the same thing as 1.5. I'm just simplifying it, times x. And so suddenly we've taken this problem and we've written it into an equation that we could graph. All right. So at this point, we don't have, I'm not going to do any equations today that have a plus b, but we can see that our rate multiplications lend themselves very easily to being y equals mx plus b. Okay? All right, so here we have something that looks almost exactly the same. In fact, the first two sentences are exactly the same. It says Joshua goes online to iTunes to buy some new songs to play at his party next weekend. The price is $1.50 for one song. If he has X dollars to spend on songs, write an equation to represent how many songs he can buy. So when we look at this, we're being asked to write an equation to represent how many songs. So the answer here is he can buy blank songs. So we know that when we're setting this up, we're going to set it up as y songs is equal to, and then thinking about my rate, it's $1.50 for one song, $1.50 for one song. Or one song for $1.50. And the situations we're going to be trying to find out about is when there are X dollars. Now when I set this one up and I think about I need my answer to be in songs, so I need to actually use this rate. One song over $1.50. And so in order to fix up my units, I need to multiply by the number of dollars, which we don't know, it's an x. So this fixes up our units because the dollars and the dollars cancel out. And so we can write this as an equation that y is equal to 1 over 1.5 times x. There's a couple other different ways we could write this. Isaac, give me another.
Y equals 15 over 1 over y. Or we can put 1 under it.
So we could multiply top times top and bottom times bottom, and we could write this as x over 1.5. This would be fine. We could take this and we could find a 1 over 1.5 is equal to, if I multiply by 2 over 2, is equal to 2 over 3. So we could also say that this is y is equal to 2/3 x. Okay, so there's several different ways that we can write this, several different simplifications that we can do. You just need to understand that all of them are appropriate depending on your usage. Which of these three equations down here would you probably want to have if you were getting ready to graph this equation? Which of these three equations would you probably want to have if you were getting ready to graph this equation? Number 2 would be the easiest to graph because it's easy to calculate and the change when it's in whole numbers. So a change in 2 in the y direction and a change in 3 in the x direction is really easy to count out on the graph. All right, let's look at one more. This problem is a little bit more complicated because there's a little bit more distracting information, but in the end, it's really all the same. So looking at this, we have our question down here says write an equation to represent how many hours. Okay, so it will take blank hours. As I read through this, where's the rate? Where's our cause and effect? This one's not as obvious as the previous two, which is why I'm going to make you think about it. Where's the rate? Where's the rate?
324 miles in 4.5 days.
All right, so 324 miles in 4.5 days. So this is 324 miles per 4.5 hours.
Oh, I mean hours.
Or 4.5 hours over 324 days. So we've got to figure out which one of those we're going to need here in a second. And this should say situation, not type of problem. The situation we're going to be finding out more about is what? Jamaria. Yeah, X miles. So if the second day is X miles, how long is that going to take them? All right, so we want to go ahead and set this up. I'm going to find out Y hours. That's my answer. Which rate do I want? Number 1 or number 2? Looking at my answer, or looking at my work, not yours. You might have written them down differently. Number 1 or number 2, which rate do I want? Good, you guys are showing me number 2 because that matches up our hours on top. 324 miles. And in order to get our units corrected, we need to multiply by our x miles so that it gets our miles and our miles to cancel out. So we can write this as the equation y is equal to 4.5 over 324 times x. Or I could write it as y is equal to 4.5x, because that's top times top, bottom times bottom, over 324. We know that these are the same thing. Are there any questions? Yes, Isaac.